What is the part about human intelligence that we have most failed to replicate with these models?
Just a lot of it still. We've stumbled by with the transformer neural network, which is extremely powerful, very general. You can train transformers on audio or video or text or whatever you want, and it just learns patterns, and they're very powerful, and it works really well. That to me almost indicates that this is kind of like some piece of cortical tissue, because the cortex is famously very plastic as well. You can rewire, parts of brains, and there was the slightly gruesome experiments with rewiring visual cortex to the auditory cortex, and this animal learned fine, etc. So I think that this is kind of like a cortical tissue. I think when we're doing reasoning and planning inside the neural networks, that's kind of like the prefrontal cortex. But I still think there's many brain parts and nuclei that are not explored. So maybe, for example, there's a basal ganglia doing a bit of reinforcement learning when we fine-tune the models on reinforcement learning. But whereas the hippocampus, not obvious what that would be. Some parts are probably not important. Maybe the cerebellum is not important to cognition, it's thought, so maybe we can skip some of it. But I still think there's, for example, the amygdala, all the emotions and instincts. And there's probably a bunch of other nuclei in the brain that are very ancient that I don't think we've really replicated. I don't actually know that we should be pursuing, the building of an analog of human brain. Maybe another way to answer the question is, you're not going to hire this thing as an intern because it comes with a lot of these cognitive deficits that we all intuitively feel when we talk to the models. And so it's just not fully there yet. You can look at it as not all the brain parts are checked off yet.